Good morning, children. Welcome back to science class. Children, I hope you are all doing well. Children, last session we have studied about lesson physical and chemical changes. Today I will be doing remaining part of the lesson. Children, we have studied about changes, the process in which there is change in state, color, shape, size, property, chemical composition and structure of a substance is called change. The changes are broadly divided into two types. They are physical change and chemical change. Here, then what is meant by physical change? A change in which a substance undergoes a change in its physical properties only. It is called a physical change. A physical change is generally reversible. In such a change, no new substance is formed. Here you can observe picture on the screen. Cutting of the wood is the example for physical change. There is no new substance formed in this change, only the size is changed. So it is an example for physical change. Then what about chemical change? Chemical change are the changes in which chemical properties of substances are changed and new substances are formed. Here you can observe the picture on the screen. Burning of the wood is the example for chemical change. After burning the wood, we will get ash. Here ash is new substance. So, the most of the chemical changes are irreversible. After burning, we can't get once again wood in a original shape. Even these new substances are formed by the result of a chemical change. Properties of the products are different from the properties of reactant. Here wood is a reactant. The wood react with, burn with help of oxygen. We will get ash. Here ash is different. Ash has different properties and wood has different properties. So the properties of the products are different from the properties of reactants. Here wood and oxygen are the reactants and ash is the product. So burning of wood is the example for chemical change. Rusting of iron. You know that rusting of iron is a chemical change. This is also a slow change and a change that is quite undesirable. Why it is undesirable? Because the rust destroys the iron particles. It goes on reducing the strength of the iron, and since you know iron is used in making bridges, ships, cars, truck bodies and many other articles. The monetary loss due to rusting is huge. Rust is formed when iron reacts with oxygen and moisture, means water vapor from the air. The material formed is iron oxide. The reaction of rusting can be written like this. Fe plus 3O2 gives 2Fe2O3. Here Fe is the chemical symbol of iron. The Latin name of iron is ferrous. So the chemical symbol of iron is Fe. When 4Fe plus 3O2 gives 2Fe2O3. Here 2Fe2O3 is an iron oxide, ferric oxide. The presence of water vapor and oxygen both are needed for rusting. Then how can we stop articles from rusting. We either stop the iron from coming in contact with air, water, or both. Then, how do we prevent rusting? Prevent iron articles from coming in contact with oxygen or water or both. One simple way is to apply a coat of paint or grease. In fact, these coats should be applied regularly to prevent rusting. You can observe some prevention on the screen. They are: we can apply oil, we can paint the iron metal, we must store iron articles properly, and another way is to deposit a layer of a metal like chromium or zinc on iron. This process of depositing a layer of zinc on iron is called galvanization. The iron pipes we use in our homes to carry water are galvanized to prevent rusting. Here, galvanizing is the process of applying zinc coating to a more noble metal, popularly steel or iron, to prevent corrosion or rusting. You know that ships are made of iron and a part of them remains underwater. On the part above water also, water drops keep clinging to the ship's outer surface. Moreover, the water of the sea contains many salts. The salt water makes the process of rust formation faster. Therefore, ships suffer a lot of damage from rusting in spite of being painted. So much so that a fraction of ships' iron has to be replaced every year. Children, have you heard of stainless steel? Most of the steel that we use at home is stainless steel. It is steel that not rust. It is made mainly iron, but metals like carbon, chromium, nickel and manganese are mixed with the steel. The common steel is made up of iron ore, coke and limestone, but stainless steel is made up of iron, the other metals like carbon, chromium, nickel and manganese. The stainless steel works really well in the industry. Next is crystallization. Crystals are purest solid form of a substance having a definite shape. Common substances such as sugar, salt and alum all made of crystals. Crystallization is the process of obtaining crystals of a soluble substance from its hot saturated solution is called crystallization. Crystallization is only a physical change because no new substances are formed during the process. It involves only a change in physical state. Crystallization is used to obtain substances from naturally occurring impure substance. In seawater, the amount of dissolved salt is very large. As a result, seawater tastes salty. It is used to obtain salt. These salts can be obtained by the process of evaporation. These salts can be obtained by the process of evaporation of seawater. This technique of separation is not good. The salt contained in this manner no pure and these crystals are very small. By obtaining crystals, we are able to purify certain substance. We have to we are able to purify certain substance. Here is an experiment to see how crystallization occurs.
Experiment to grow crystals of copper sulfate. What is crystallization? The process of obtaining crystals of a soluble substance from its hot saturated solution is called crystallization. Crystallization is only a physical change because no new substances are formed during the process. It involves only a change in physical state. Crystallization is used to obtain pure substances from naturally occurring impure substances. Here's an experiment to see how crystallization occurs. Take 100 milliliters of water in a beaker and heat it on a Bunsen burner. When water begins to boil, add about 2 milliliters of dilute sulfuric acid and then a spoonful of CuSO4. Stir the contents with a glass rod. Stir it continuously and add more impure copper sulfate until no more of it dissolves. Fasten a thread in the middle of a wooden stick and suspend in a glass. Stop heating and pour the saturated copper sulfate solution in a glass. Place the glass aside and cover the beaker with a cardboard. Leave the setup for 24 hours. After 24 hours, you will find big blue crystals of pure CuSO4 at the base of the beaker. Then remove the crystal from the glass and dry in warm air.
Children, today we have learnt about rusting of iron. If a piece of iron is left open for some time, it acquires a film of brownish substance. This substance is called rust. The brownish layer is formed on the particles of iron that is known as rust, and this process is called rusting. Rusting takes place in the presence of both oxygen and water vapor. One simple way to prevent rusting is to apply a coat of paint or grease over the metallic items. Another way is to deposit a layer of a metal like chromium or zinc on iron. Another way is to deposit a layer of a metal like chromium or zinc on iron. Next one, we studied about galvanization. The process of depositing a layer of zinc on iron is called galvanization. Then it is the process of getting crystals of pure substance from their solution is known as crystallization. Children, hope you have understood the lesson. Children, next week you are having FA2. Children, please read the lesson. I will be posting FA2 revision in WhatsApp group. Please follow that. Children, read textbook. Take care. Thank you.